Hi, this video is going to go over the practice test 3. So we have the note sheet here that you're going to have for the exam that walks you through all of the hypothesis tests. Keep in mind this table, even though it doesn't say confidence intervals, is useful in the same way for the intervals. In that if you have one sample and you're dealing with a proportion, even though this says 1 prop z test, if you're doing an interval, you would just choose 1 prop z int. And if you're doing one sample for the mean, you would do a t interval if the standard deviation is not unknown, and a z interval if the standard deviation is known. So this table's just as useful for the intervals. You just choose the exact same thing, just with int at the end instead of test, if it's an interval question. Hopefully that helps you a little bit as well. So that is the note sheet. On here, it's helpful to pick a test, and then this column, null alternative, will help you write your H0 and H1. Remember, the one samples are numbers. The 2 samples are compared to each other. If it's dependent, you're relating that difference to 0. And then the chi-square tests are words. And then the last column are things that you should just check. Is it a normal population? Are your proportions greater than 5%? Are the cells greater than 5? Just things to check to make sure it's okay to do that test before you start. I'm not going to come back here each time, but I will mention what steps I followed through here while I was doing, choosing the tests or the intervals that I was doing for each problem. All right, let's jump in. In the video, I'm just going to do the first example, but just like each other practice test, there's a second example. When I post the answer key, it will have both answers on the key. All right, so first question. You want to obtain a sample to estimate a population mean. Based on a previous evidence, you believe the population standard deviation is approximately 24.5. You would like to be 90% confident that your estimate is within 2 of the true population. That means we want our margin of error to be 2. How large of a sample size is required? So because we're given the standard deviation, we're going to use the n equation that has standard deviation in it. So this is that equation. Z is our critical value, and the one that goes with 90% is 1.645. So we would do that squared. The standard deviation is 24.5 squared from the problem. And that goes over the margin of error squared. So we're going to type that right in the calculator. 1.645 squared times 24.5 squared divided by 2 squared. And we get 406.07. And you always round up, so we would need to ask at least 407 people. All right, next problem. You work for a company that produces electronics with integrated circuits. One of your products is designed to automatically shut down if its operating temperature exceeds 175 degrees Celsius. The manufacturing process has been designed to have a standard deviation of 0.3. So if it's designed that way, that's going to be the population. You test a random sample of 20 items. So our sample size is 20. You record the following shutdown temperatures. Construct a 90% confidence interval. So we have a sample here. It's not percent, so that means we're going to be doing means. And we're given a population deviation, so we're going to do a z interval. So I need to put this data in my stat menu. So I'm going to go to stat edit. And I'm going to type this into L1. So 174.6, 175.6, 174.6. A lot of these are the same, so I'm going to mark them as I put them in and double check. $75.4. Okay, I'm just going to double check one more time. Where am I? Okay. When they're all so close, it makes it hard. 3. Okay, numbers are in there. So now I'm going to go to Z interval, and data. My standard deviation is 0.3. My list is L1. I'm going to make sure that's right. Frequency is 1. C level is 0.9. Calculate. So on the practice test, it asks for the critical value and the standard error, like your homework. The homework was weird that sometimes it was using different critical values. So what I would be looking for would be the critical value that goes with 90%, which would be 1.645. My Open Math would mark that wrong. And then standard error should be standard error of the mean. So that would be the standard deviation divided by the square root of n. So 0.3 divided by root 20. 0.3 divided by square root of 20, which would be 0.067. I'm not going to ask that on this test. I decided when I made the test today, instead I'm going to ask like I did on the quizzes. I'm going to say, what interval did you do? Z interval. Why? Because it was means and we knew the standard deviation. Then I would say, what did you type in the calculator? So we would say we typed 0.3. We would say we used L1, frequency of 1, 90%. And then you would write the confidence interval, which is the part you get in parentheses. 175.01 to 175.23. And that would be, so this teal part here, the type of interval, what you typed in the calculator, and then the actual interval is the question that will be on the real test. So I hope that makes sense. And if you had questions on the homework about this, I'm going to fix that for next time. I am not really sure what happened with that. But the real test is going to ask these questions. What's the type of interval and why? What did you type in the calculator? And what's the interval, like I did on the quizzes? All right, let's go to the next question. Many people feel that cereal is a healthier alternative for children over glazed donuts. This table contains the amount of sugar in a sample of cereal that is geared towards children. Estimate the mean amount of sugar in children cereal using a 99% confidence level. So this time we're doing mean, but the standard deviation is unknown. So we're going to do a t-test. So t-test, because the standard deviation is unknown, not t-test, t-interval, because we're doing intervals. Standard deviation is unknown, so I'm going to put that in L1. 8, 13, 13, 12, 10, 12, 12, 9. 13, 12, 12, 8. 12, 15, 15, 10. 10, 12, 16, 12. Okay, so t-interval, because the standard deviation is unknown, we go to tests, we pick t-interval data, so L1, frequency is 1, 99%, so we're going to change this to 0.99, and then calculate. So the interval is 10.414 to 13.186. And then it says interpret. So interpret is we are 99% sure that the true proportion, true mean, we're talking about means, is between 10.414 and 13.186 for sugar in children's cereal. Now I want to know what's in glazed donuts. All right, let's look at the next one. A simple random sample of n is equals 15 is drawn from a population that's normally distributed. The sample mean is found to be 42, and the sample standard deviation is found to be 12. Construct a 95% confidence interval from the population mean. So we're still dealing with mean, so it's going to be a t-interval because we have the mean, but we have no population standard deviation. Unknown. Okay. So t-interval. This time we're going to go to stats. So our sample mean is 42. Our sample deviation is 12. Our n is 15. And we want to be 95% confident. So that is 0.95. Then we calculate. And we get, in parentheses at the top, 35.355 to 48.645. That is the confidence interval. All right, let's check the next one. Out of 800 people sampled, 205 had kids. Based on this, construct a 95% confidence interval for the true population proportion for people with kids. So population proportion tells us we're going to do one proportion, z int, because we're dealing with proportions. So stat test, one prop z int. So you have to scroll all the way down to the int one prop z int. X is the number of people that answered, so 205. N is the number of people that we asked, so 800. And then C level is the percent, so 0.95. And then we calculate. So our interval will be 0.226 to 0.287. So that would be our confidence interval between 22.6% to 28.7%. All right, let's look at number 7 here. If n is 240 and p hat is 0.3, remember p hat is x over n, construct a 90% confidence interval. So this is the same question. We're doing a one prop z int because it's giving us a proportion. So we have to find x because it gave us the percent. So x is 0.3 times 240, 72. If we had gotten a decimal, we'd have to round to the nearest whole number because you have to put whole numbers in. So in the calculator, stat, tests, one prop z int. So x is going to be 72. N is 240. And this time we're doing a 90% confidence interval. Calculate. So we're going from 0.251 to 0.349. So that's just a different way to do it if they give you a percent instead of the X. All right, let's go to number 8. Political candidate asks you to conduct a poll to determine what percentage of people support her. If the candidate only wants a 6% margin of error, so that means our E is going to be 0.06, at a 95% confidence level, so the Z that goes with 95% is 1.96. What is the sample size that's needed? We weren't given a standard deviation, so we're going to have to use the other formula. So this is the one where we do Z squared P hat Q hat over E squared. So Z is 1.96. We weren't given a previous percent. So when it's unknown, we use 0.5. Q is 1 minus P. So 1 minus 0.5 is 0.5. And then E is that 6% margin of error from our problem. So we type that in the calculator. Divided by 0.06 squared. We get 266.8. And we always round up no matter what. So 267 people is how many we would have to ask. All right. A random sample of 75 students at the University of Minnesota spend an average of $914 per month, $900.14 per month in rent, with a standard deviation of $321. The distribution is moderately skewed to the high end. Which of the following statements are true? So we know we're a little bit skewed to the high end. So that tells us we probably have to use T instead of Z. We also don't know a population deviation. So let's do a T interval just to get numbers. The reason I know that is because I know the question. But if we keep reading, 95% of students at the university spend $840 to $988. So when we read that, it's giving us an interval. So I know we're going to have to make an interval. So let's do a T interval to see what we get for numbers. So stats, our sample mean is 914. Our sample standard deviation is 321. Our N is 75. And then in these, it's saying 95%. So if we do that, our interval is about 840 to 988. That's where they're getting these numbers. So the numbers fit with the ranges they're giving us. So now we're looking at if their interpretations are correct. So part 1, 95% of the students at the university spend $840 to $988 on rent. That's not what a confidence interval means. We are 95% confident that the average rent for students at the university is between $840 and $988. That is what it means. And then because we cannot examine other characteristics of the students in the random sample, it's not advisable to construct a confidence interval. All we need to do the T interval is the sample mean and the sample deviation. So 2 is accurate. So out of our choices, is 1 correct? No. Is 2 only correct? Yes. So the answer to this would be we can interpret the mean, the interval this way. So it's weirdly worded, but that's all it's saying is how can I find and interpret that interval? All right, now it looks like we're going into hypothesis testing. All right, a well-known brokerage firm executive claimed that 12% of investors are currently confident of meeting their investment goals. An XYZ investor optimism survey found that in a sample of 600 people, so we asked 600 people, 17% of them said they are confident. of meeting their goals. Test the claim that the proportion of people who are confident is larger than 12%. So if we're trying to test that a proportion is larger than 12%, we're dealing with one sample and it's a proportion. So we're going to do a 1 prop Z test because we have one sample and it's talking about proportions. So if we want the proportion to be larger than 12, H naught is always the same number in equals. So H naught, P equals 0.1. H1 is P is greater than 0.1. It doesn't tell us a level of confidence, so alpha is 0.05. And then it tells us, we ask 600 people, but it gives us a percent. So 17% of 600 is 102. So our X is going to be 102 people. So now let's do the test. 1 prop Z test. What does it ask? So it asks us what our P is, 0.12. Then it asks us what our X is. We just said that was 102. N is 600. Because like I said with the confidence intervals, I'm going to ask you the same thing I did like for the quiz. What did you type in the calculator? And then we want it to be greater than. So then we calculate. So our test statistic is Z. Z, goodness gracious. Z is 3.769. P is 8.19. As soon as we're greater than 1, that tells us we're 0. P is 0. Then we compare. 0 is greater than 0.05. So P is greater than alpha, which means, nope, 0 is not greater than 0.05. Brain cramp. P, 0 is less than. P is less than alpha, so we reject. Rejecting means we do have evidence. So there is evidence to say the proportion of people, of confident people, is larger than 12%. So rejecting means there is evidence to support H1. All right, let's go to the next one. The sample consisted of 75 night students with a sample mean of 2.87 and a standard deviation of 0.25. And then 20 day students with a sample mean GPA of 2.86 and a standard deviation of 0.43. Test the claim that the mean GPA of night students is smaller than the mean GPA of day students at the 0.25 significance. So we're dealing with two means. They're independent groups because they have nothing to do with each other. And we don't have a population deviation. So we're going to do a 2-SAMP t-test. Because we have two means, no population standard deviation. Unknown. Okay. We want to know if night is smaller than day, and we listed night first. So proportion 1, H naught is always equals. Proportion 2, H naught is less than. So you can write it as 1 and 2. You can write it as night and day. Whatever's easier for you, as long as you find some way to tell me which one's 1 and 2. Then it says the 0.025 level of significance. So that's our alpha. Then let's go do it. So we're doing the 2-SAMP t-test. This is stats because we're not given a table of data. Then we're going to need to write what we put in the calculator. So x1 is 2.87. S1 is 0.25. N1 is 75. X2 is 2.86. SX2 is 0.43. N2 is 20. And then we want group 1 to be less than group 2. So I pick less than, and then pooled is always no, calculate. Now, if you write things down like this, just number the problem, take a picture, and upload that in that section. That counts. And you can put in that calculator thing on paper. Or you can just type them in the order you put them in the calculator. If you type them like this, comma this, comma this, and so on, then I'll know that that's what you typed, and I'll be able to figure out which is group 1 and group 2. That's the easiest way to tell me what it is, or you can type it somewhere in the problem. It's up to you. Now scroll up. Test statistic. T equals 0.0996. P is 0.539. So now we compare 0.5 is greater than 0.025. So P is greater than alpha. We do not reject, which means there is not evidence to say night GPA is lower than day GPA. All right, let's look at the next problem. The weights of newborn children in the United States vary according to the normal distribution with a mean. So if we're talking about the whole United States, we're talking about the population mean is 7.5. And standard deviation is 1.5 pounds. An article claims that the average birth weight is decreasing over time. A local hospital wanted to see if the claim was true and randomly sampled 18 babies' weights and found an average weight of 6.9 pounds. Test the claim using a 1% level of significance that the mean weight is significantly smaller than the national average of 7.5 pounds. So we have one sample. We're talking about mean, and we know the population deviation. So that's going to be a z-test. We have one mean, and we know the population deviation. So we're testing that the mean weight is smaller. So H0 always equals, and then H1 is going to be smaller. We're using the 1% level of significance, so it'd be 0, 1. So now let's do it. Z-test, stats, because it's just giving us a list of things. So in the calculator, I'm going to type 7.5 for the mean. I'm going to type 1.5 for the standard deviation. X bar is 6.9. N is 28. 18. So because they told us this was 18, because they told us it was normal, we're okay. Should have a bigger sample size. And then we're looking for less than, so we need to choose that one and then calculate. Z is negative 1.697. P is 0.045. Now we're going to compare. 0.45 is greater than 0.01. So if they hadn't given us that 1% level of significance, this would be different. But because they changed it to 0.01, P is greater than alpha, so we do not reject. there is not evidence to say mean weight is smaller. So if we were doing the standard 5% level of significance, we would be fine. But because they changed it to 1%, they're saying, hey, this is more important. We're going to say there's not enough evidence. So that level of significance does matter. All right, let's look here. Is there a difference between community college statistics students and university statistics students in what technology they use? Is there a difference? Okay. Of randomly selected community college students, 47 use a computer, 89 use a calculator with built-in statistics functions, and 38 use a table in the textbook. Of the randomly selected university students, 28 use a computer, 79 use a calculator, and 39 use a table from the textbook. Conduct the appropriate hypothesis test. So they're asking, is there a difference? They're giving us a big table. So that tells us that we're going to do the chi-squared test. One, it has too much data to be able to be one sample or two sample. And they're saying, is there a difference? So the is there a difference is the question that tells us that. So that tells us our H0 is that they're the same. Our H1 is that they're different. It doesn't give us a level of significance, so it's 0.05. So now we need to put this in a matrix. Where I drew this, I could just say for the calculator, I could put matrix, or I could put like community college row 1, university row 2, something like that. I could put matrix 2 by 3, just something to tell me that I know you knew you did a matrix. So I'm going to go over to edit. It is a 2 by 3, 47, 89, 38, 28, 79, 39. And now I go to stat, tests, down to chi-square test. As long as you put it in A, you don't have to do anything different. Okay, my chi-square is 2.99. My P is 0.22. When I compare those, 0.22 is absolutely greater than 0.05. So P is greater than alpha, so we do not reject. So there's not enough evidence to say community college and university students use technology differently. All right. Test the claim that the proportion of men who like cats is smaller than the proportion of women who like cats. So proportion of men, smaller, proportion of women. H0 is always equals. Okay, so we're comparing two proportions. So that's the 2 prop Z test. Because we're comparing two proportions. All right, let's keep reading. At the 0.025 level of significance, so that's alpha. Based on a sample of 50 men, 25% own cats. So 25% of 50 is 12.5, so that gives us 13. 12.5 rounds up to 13. And then based on a sample of 70 women, 36% own cats. So 0.36 times 70 is 25.2. So that rounds down to 25. So now let's do our 2 prop z-test. X1 is 13. N1 is 50. X2 is 25. N2 is 70. We're saying that men is less than women. Calculate. Z is negative 1.128. P is 0.130. Now let's say you had, instead of 13, you had said 12 here, like you rounded down where it was the 5. Let's see what kind of difference that makes. Negative 1.370. P equals 0.085. So that one difference, that's all I changed, right? 1250, 2570, yeah. That one difference made that change. So that's why doing this is important. Because if you put 12 here on the calculator, I might say, hey, you rounded wrong and take off 1 point, but then I'm going to grade the rest of it based off that 12. Like I'm going to go redo the numbers and I'll look at your test statistic, p-value, result, and statement based off the numbers you typed in the calculator, and you'll only lose 1 point. If you don't tell me that you typed a 12, all 5 of those are wrong. So it's better to lose 1 point than 5 points. So that's why I want to show you that. So now, oops, that's not what I wanted to do. We'll go back and compare. So P 0.13 is greater than 0.02. So P is greater than alpha. Do not reject. There is not evidence to say more men own cats than women. Nope, less. Wait. Yes, fewer men. Got to read the question right. Fewer men cats than women. All right. Let's see here. 42% of California residents are Latino. 42. 34 are white. 12 are Asian or Pacific Islander, and the rest are other races. You want to see if the students at the California community colleges match the California population as a whole. So we're trying to say, does it match? Okay. You surveyed 290 community college students. 128 of them were Latino, 97 were white, 38 were Asian or Pacific Islander, 27 were of other races. Use a 5% level of significance. So what test type? This is going to be a chi-square GOF because it asks you, does it match? That question tells you chi-square GOF. So now that means we say, does it fit or doesn't fit? So it either fits or doesn't fit. They tell us 5% level of significance. So we need to figure out the expected value. Well, percents add up to 100. So if I subtract 42, 34, and 12, I'm left with 12%. So if there's 290 people, to figure out each one, we're going to do 42% of 290 is 121.8, so 122. 34% of 290 is 98.6, so 99. 12% of 290 is 34.8, so 35. So now add those up. 122 plus 99 plus 35 is 256. 290 minus 256 is 34. So you could do it so that these two numbers are the same because they're both 12%. Or you could subtract and get the 34 because it says the rest are other races. Either of those is fine. Just make sure you find a way to tell me what you put in. This question will probably ask you, what did you put in for the expected? So I know which number to check. That way I know if you did 34 or 35. So I'm checking your numbers correctly. So stat edit. On the note sheet, it says observed goes in L1. So this is L1, this is L2. 128, 97, 38, 27. And then this, 122, 99, 35, 34. And then we do stat, tests, chi-squared GOF test, L1, L2, degrees of freedom. So there's 1, 2, 3, 4 categories. So we need to subtract 1 and put 3. Scroll over. So chi-squared is 2.034 and P is 0.565. Now let's see what happens if we change that to 35. So if this was 35, you'd have 2.421 and 0.490. So that's why I need to know in that calculator question which things you put in your expected. Either way, the result is that P is greater than alpha, so you do not reject, which means there is not evidence to say the community colleges are different from the state as a whole. All right. 10 individuals went on a low-fat diet for 12 weeks to lower their cholesterol. The data are recorded in the table. Do you think there's evidence to show that their cholesterol levels were significantly lower after the diet? So we have 2 samples, but it's the same person. So this is going to be in matched pairs. So this is going to be a t-test, but it's matched pairs. So we're going to do that L3 list where we subtract things. So we're going to put the starting in L1, the ending in L2, and then in L3, we're going to do L1 minus L2. So L1, 140, 220, 110, 240, 200, 180, 190, 360, 280, 260. Okay. Oh, nope, 140. Okay. And then L3, I arrow up to the top, do L1 minus L2. Okay. If they are lower after the diet, this number minus this number should still have something left. So our H naught is going to be mean 1 minus mean 2 equals 0. That means they were the same. And the mean 1 minus mean 2 should be greater than 0. Because if the numbers got smaller, we'd still have something left. It does not give us a level of significance, so it's 0.05. So, what did I do? I did something. I gotta go do that again. L1 minus L2. Okay. Stat, tests, t-test. This time I'm going to choose data. My mean is 0. I'm going to do it with L3 so that I make sure I use the subtracted data. L3. Frequency is 1, and I'm going to choose greater than. Calculate. So my test statistic, 1.174. P is 0.135. So in this case, P is greater than alpha, so we do not reject, which means there is not evidence to show the diet lowered cholesterol. All right. And then we have this one. A restaurant manager is interested in investigating whether the dessert ordered depends on the main course. What can be concluded at the alpha equals 0.5 level of significance. So it's asking us if it's dependent. So that's chi-squared test because it's saying dependent. For that, H0 is independent. H1 is dependent. They tell us it's the alpha equals 0.5 level. So we're going to put this in a matrix, and it's 3 by 3. So to get to matrix, in case you forget, it's second x negative 1. Over to edit, we're going to make it a 3 by 3, and then I'm just going to type them in. 85, 97, 52, 75, 98, 57. 128, 102, 25. Okay, and then I go to stat, test, chi-squared test, leave that all the same, and I get chi-squared is 27.695. P is 1.4, that's greater than 1, so P equals 0. P is less than alpha, so we reject, which means there is evidence to say dessert ordered depends on the main course. All right, so that is the practice test. Don't forget you have that note sheet. Let me know if you have any questions before you jump into the test, and good luck.